You really have no questions of your own? Yeah. Number 90? Okay. That's it? Okay. So I think what I'll do is, because I'm recording this anyway, I might work backwards, because we got up to like number 29 in the morning, and then if I don't get the chance to do it with the rest of them tomorrow, then at least it'll be recorded. Yeah? Okay. Number 90, there we go, okay. So we're going to start with number 90, which is on page 17. I'll just give it a minute to brighten up a little bit there. A saturated solution is prepared by dissolving a salt in water. Which of the following graphs could represent the ion concentrations if a different anion, not shown on the graph, slowly precipitates some of the cations? So I'm just going to have my salt A, B, A plus, B minus, and I'm going to add a different anion. I'm going to call it X, okay? And X slowly precipitates with A. So what's going to happen to your concentration of A? It's going to go down. Actually, I don't like any of these graphs. But, you know, let's see what we do. So it goes down, and then what's going to happen? It's going to shift to the right. So that means that A and B are both going to go up. So I don't really like any of these graphs. I think they're terrible. I would say E, none of the above. Yes? Because if I'm slowly precipitating my cation, what should happen then is my cation should slowly go down. Yeah? But then it should come back up, but not quite to where it does, and my anion should be slow. I don't know. It just, that's a terrible question. Thank you for asking it. Remove that one from my problem set because I don't like it. All right, working backwards, number 75. An equal number of K2SO4, moles of K2SO4, is added to 4 different 10 milliliter samples, and a precipitate forms in all but one of the samples. Which sample did not form a precipitate? So I need something that is not going to precipitate with SO4 2 minus. So I'm going to go back here and calcium, strontium, and barium will not precipitate with SO4 2-. So let's see what my choices were. Well, that's a bad question too, isn't it? Or did it say, hang on. Oh, those were low solubility. Okay, okay. So this will precipitate, and this will precipitate. Beryllium was not on the list of low solubility. So it would be C. Ooh, I missed 78. 78. The KSP for cadmium carbonate is 1.0 times 10 to the minus 2. What is the solubility of cadmium carbonate at 25 degrees Celsius? This is going to give you an opportunity to use the shortcut method for multiple choice. Yes? You guys know the shortcut method? We have an AB salt, which means that it is a 1-to-1 ratio. And if you have a 1-to-1 ratio, KSP is equal to, are we looking for the review? What? KSP is going to equal x squared, where x squared is the solubility. And so if we want to know the solubility, then we would need to just take so x would be the square root of the KSP, which is 1.0, times 10 to the minus 12. And I don't think I'll do the math on that unless you want me to. Well, I'm here, might as well, I guess. 1e12 negative square root, and we get 1 times 10 to the negative 6. Is it not there? It's called review, and it's like a, oh, sorry. Okay, so it's 78, 75. Let's see what else. 73, 72. Which of the following saturated solutions has the highest concentration of lead? Well, if you had, are we looking for another one? Oh, okay, good luck. I'm not quite entirely sure that I have more, but we'll see. Which of the following has the highest concentration of lead? If I had lead nitrate, that would be our winner, yes, because nitrate is soluble with everything. However, this one isn't, so you're going to have to then go look at the KSP values for lead bromide, fluoride, chloride, and iodide. Lead, ooh, other page. Lead, fluoride. Where's lead? Oh, bromide, chloride, and iodide. I don't see fluoride. I wonder why. As we get further along in there, I'm taking these questions from other sources, so they may not always be the best questions. So the ones at the beginning were actually old provincial exam questions, so they were like vetted, and they went through like an actual process. Oh, not that one, lead chloride. So out of those three, the one that would be least soluble would be lead iodide, but let's see if I've missed something. I don't think I have. I'm really not sure. I think that's just maybe a bad question. I think of the three, the highest concentration of lead would be the most soluble, and I think that was lead chloride, but I'm not sure. We don't have time to decorate a door in Chemistry 12. It's sad, but it's true. It's like, anyway, okay. I wish we did, but we don't. If I had grade 9s, we'd definitely be decorating a door. Okay. So yeah, which one has the highest concentration of lead? That would be the one with the largest KSP. And I'm going to ignore fluoride because it's not on my list, so I don't know what's up with it. So that would be bromide, chloride. That would be chloride because it's 10 to the minus 5. It says it's A, which is the bromide. Well, that's just so messed. I'm just really unhappy with that question altogether, and we're going to throw that one out as well because it is terribly problematic. Okay. Did we find one or no? Okay, I'm going to print another copy. Chem 12, review. Solubility, 2021. There we go. File, print. Oh, it'll be the one in the staff room, so I have to release it. Unfortunately, I can't send you. I don't want it to go to OneNote. I want it to go somewhere else. This is why when I say I'll just print something for you, it takes me so long because every little step takes so long. School copiers. See, I've clicked on it and nothing's happening. Hello. Hey. What just happened? Okay, I'm not going to print it. I can't. I'll print it later. Okay. Oh, hang on. Properties. Okay. Two on one. Top left line. 3 at the top. I'm going to make like, I don't know, 6 because I don't know how many other people are going to have lost it because so many people lose it. And I know that my block 4 is notorious for that. So I'm going to press print. Okay, you guys are going to wait a minute for me. And Chris, you're going to come with me. So extra copy should be here momentarily. Yay! All right, and I need to go to here. There we go. All right. Which of the following saturated solutions has the lowest concentration of carbonate? Well, let's go look up carbonate. Well, which one can we automatically get rid of? Do you guys know anything about ammonium? It's soluble with everything. And so if it is soluble with everything, that means it's going to have one of the highest concentrations of carbonate, yes? Because lots can dissolve, so it's not going to be that one. We're now going to have to choose between magnesium, calcium, and strontium. My guess is that magnesium is 10 to the minus 6. Strontium is 10 to the minus 10. Ooh, so strontium is going to have a lower concentration than magnesium. Does that make sense? Because its KSP value is lower. And it has the same ratio of strontium to carbonate as calcium to carbonate. Yeah? So strontium is going to have a lower concentration of carbonate than magnesium. Now let's check out calcium and see where it rates. Calcium carbonate is 10 to the minus 9, so it's not as low as strontium. So the lowest concentration would be the one with the lowest KSP value, which would be our strontium carbonate. Okay? Solubility. There we go. Oh, we ended up at the beginning. That's exciting. Ah. Oh, so much fun. Where are we at? Okay. Okay, so our answer there was D. All right, let's see, 68. Which of the following solutes forms a saturated solution when 0.1 moles is dissolved in 1 liter of water? What is special about 0.1 moles per liter? That's the definition of where soluble is, yes? So if something is soluble, you can make a 0.1 molar solution, which means it will not be saturated at 0.1 moles per liter. So if something is soluble, it will not be saturated at 0.1 moles per liter, okay? And so what that means is that if we want something to actually be saturated, if we put 0.1 moles in 1 liter, we have to find something that is low solubility. Okay, so we're going to go and we're going to look up our sulfates. Certainly it's not going to be ammonium, because ammonium is soluble with everything. We can look up calcium sulfate, magnesium sulfate, and magnesium sulfite. I'm going to guess right now that it's my sulfite because I know it's at the bottom of the table, but let's just double check. Ooh, calcium sulfate is low solubility. Magnesium sulfite is low solubility. Oh, so this question has two answers. That's just peachy. Okay. So I feel like I'm going to, in that question, maybe replace magnesium with strontium or barium, because then I would have only one answer. No, that's not right. If I replaced calcium with beryllium, so if I had beryllium sulfate and magnesium sulfate, that would work better. Let's see. This went much better this morning because we were doing all the earlier questions that came from real exams. Okay, and we want to go here. Okay. So yeah, I'm going to change this one to beryllium sulfate, and then our answer would be C. Okay? So I need to change the question, but probably I don't even know, the answer key might not be. You could just get rid of 68 for now. Okay, that might be the easiest thing. I'm just writing a note for myself. And I don't know why it says Ca2SO4, because that doesn't work either. Anyway, regardless, number 67. The following equation represents the equilibrium in a saturated solution of iron 2 fluoride. In a saturated solution, fluoride is 1.68 times 10 to the minus 2. What is the molar solubility of FeF2 at 25 degrees Celsius? Well, if we let X be the solubility, then we have, this is X and this is 2X. So fluoride is 2X, yes? The solubility is going to be X, so it's going to be half that quantity, yes? So that would be 0.84 times 10 to the minus 2, which would be 8.4 times 10 to the minus 3. This question needs correcting as well. Okay. Let's see what else we have here. Oh, 51. Which of the following equilibrium systems is described by a KSP? Number 51. Well, that would be that one, yeah? That's the only one where we have our solid on the left and our dissolved ions on the right. Yeah? It can't be C because the solid's on the wrong side. Okay? Okay. Let's take a look. I think 36 is the next one. Which of the following can be used to produce a 0.2 molar solution? What does it mean if something is 0.2 molar? That means it is soluble, because you have to be able to make, if you can make more than 0.1 molar, it must be soluble. Okay. So we would have to go through, I'm going to guess that it's beryllium chloride, because chloride only precipitates with lead and silver and mercury. Okay, chloride is fairly soluble. Yep. So beryllium chloride would be good. Beryllium hydroxide would be low solubility, and so would beryllium sulfite and carbonate and phosphate. And that's it for ones I did not cover with my other class. Would you like me to do any more questions, or would you like to move on to acids and bases? I can also do some written response if you'd like. What would you like? Talk with your partner and tell them what you would like. More of this, or moving on to acids and bases? Yes. Number 3? Number 3 in the written. Explain why a precipitate of silver chloride will not be produced when 20 milliliters of 3 times 10 to the 6 molar AgNO3, I'm going to put that up there so it stays with it, is mixed with 30 milliliters of 1 times 10 to the minus 4 molar NaCl. So we have 2 solutions and we are mixing them. What kind of calculation do we need to do before we can work with these ion concentrations? We need to do a dilution. Do you guys have a favorite method for dilution? Noon? Okay, so we're going to do noon with this. So our new volume, it's funny because my morning block likes M1V1. So, okay. So if you do watch the video, if you're interested, there is going to be a video posted with their questions like up to number 36 from this morning. So if you had any questions about those, you can take a look at that. But yeah, they like M1V1. Anyway, so new volume is 20 plus 30, which is 50 milliliters. So silver, concentration of silver diluted is, that's our new concentration, is equal to our old concentration, 3 times 10 to the minus 6 molar, times our old volume, 20 milliliters, over our new volume, 50 milliliters. So 3e6 negative times 2 divided by 5 is 1.2 times 10 to the negative 6. Our Cl, because our precipitate that we're concerned about is AgCl, concentration of Cl diluted is equal to our old concentration, 1 times 10 to the negative 4 molar, times our old volume, 30 mils, over our new volume, 50 mils. And we get 1e4 negative times 30 divided by 50 is 6 times 10 to the negative 5. So if we do our calculation on that, then we have AgCl, and because this is a written response, you would want to write all of this out, Ag plus Cl minus. KSP is Ag plus times Cl minus, which is going to equal then 1.2 times 10 to the negative 6 times 6 times 10 to the negative 5, which is 7.2 times 10 to the negative 11. And this is our trial KSP, not the real KSP, yes, or we could have called it Q. You can always stick that trial on the front if you do like me and accidentally write KSP instead of writing Q. That works. And so that is Q 7.2 times 10 to the negative 11 is less than KSP, which is 1.8 times 10 to the negative 10, and therefore no precipitate is formed. And by the way, if you didn't notice, one of the things that you picked up is an answer key for the written response, okay? I didn't mention it, but one of the things you picked up is the written response answer key. So if you're looking at things tonight and you want the answers, well, there they are. I finally got it finished over the weekend. It was so close to being done, and it didn't happen last week. What would you like to happen now? And don't answer nap time, because I would be very tempted. Nap time would be good. Would we like more solubility questions, or would we like to move on to some acid-base? We don't want to move on to acid-base? You're saying yes, you do want to move on to acid? No, you don't. Okay. We are going to move on a little bit. I did with block 1, but would we like to do a few more questions, or do you want to work on your own for a little bit? What do you want to do? You want to work on your own for a bit? Okay, work on your own for a bit at around, let's see, what time is this class over? At around, I'll give you like 10, 15 minutes, and then we'll do some acid-base stuff. Just start it, just a little bit. Okay? You should have done all of it up like A through E already on your own, and so we'll be reviewing it. Let's see, attendance. Oh, but I have to stop recording first. Stop recording.